it would be helpful to provide some explanation of how to simplify the SOP for a 5-variable K-map. So the same lecture material that I had posted at the Hardware Lab 4, I have actually put together these couple of files to explain the same thing. So here I take a table of 5 variables. Let's call the variables as A, B, C, D, and E. For a 5-variable K-map, 2 to the power of 5 is the number of combinations you would have. So the range of numbers go from 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. Somewhere in between, the 16th number is 0, 1, 1, 1, 1, and it continues all the way up to 1, 0, 0, 0, 0, and ends with 1, 1, 1, 1, 1, which is the 32nd number. So in your gas pump project, we have the two inputs as nozzle and pressure, and the three present states are Q2, Q1, and Q0. Your outputs are the next states, which are, let's call them as D2, D1, and D0, corresponding to Q2, Q1, and Q0 present states. And the pump, let's call it as PN for pump, that is another output. So you would have written out the state transition table with the present state as S0, S1, S2, S3, S4. The state 0 representing reset, state S1 representing pump on, state 2 representing pump off because the pressure indicator has come on, S3 pump on again because the pressure indicator went away and it led to pressure pump coming on again. Then, as this state is after the pressure indicator had come on once, the problem statement says if the pressure indicator comes on again, it should go into shutdown state. So, if these are the number of states for a Moore design you would have, how many digits does it need in order to represent a 3-bit number, represent a number that is decimal 5, which is 1, 2, 3, 4, 5 states in total. Basically, it needs a 3-bit because 5 can be represented as 101, which is a 3-bit minimum. So that means you can use any of the digits with that a 3-bit number can represent to represent any of these states. So let's say you will represent them with 000, 001, 100, 101, 110, anything that you want. So basically those are your present states. The representation of this particular state you are in is the present state. Then, combined with the two inputs, which are the nozzle and the pressure, make up for your input set. Now you would want to define the next states for the flip-flops, with these being the present states and these being the other set of inputs. You want to define what's the state of the flip-flops at the clock transition. And at every state, due to these inputs, you also want to determine what is the pump status. Okay, that is really the output of your system. Okay, so assuming that you wrote the circle diagram or the state diagram and converted it as a state transition table, the next steps would be to create a variable map. Because there are 5 variables here, you would need a 5 variable K-map. So to go and write a 5 variable K-map, you would begin in this manner. You still would use a 4 variable K-map in a doubling manner. That is, you would take 2 4 variable maps and use the inputs in the manner it's written. For the first 16 in this table, we have A as 0. So we take those numbers and put them here. And B, C, and D, E would be the variables, the 4 variables for the first map. So if you see, this just runs as a 4 variable K-map combination, where this is 0, 0, 0, 1, 1, 0, 1, 1. In the vertical side, 0, 0, 0, 1, 1, 0, 1, 1. Likewise, for the next set of 16 numbers, the A is 1 in this map. We write the 4 variable map again, keeping B, C, and D, E as the variables. Again run 0, 0, 0, 1, 1, 0, 1, 1 along this manner, and same way 0, 0, 0, 1, 1, 0, and 1, 1 along the vertical. So basically we covered A as 0, one of the variables as 0 for the first 16 locations, and A is equal to 1 in the second 16 variables locations. So now, in order to use this K-map for your project, basically you would locate wherever the zeros and ones and don't cares are and populate the table in the locations. If it is the first 16, you would put them in the first map, and if they are in the second block, you would put them in the second table. For example, in my posted material, I had given an example of how to use this K-map, 4 variable K-map written as 5 variables, how to go about simplifying them. So, if, for example, the locations of ones in this map are 1, 3, 4, 9, 11, 12, 17, 20, 22,